We reduce this tensor product here, and we want the Young diagrams to stand for irreps of SU3. Okay, so let's just take this, and the first step, we write some numbers into the boxes, 1s on the first row and 2 on the second row. And now we have to add the 1s in some way to our first diagram. So we can add both 1s here. And then what are the options for the 2? The 2 could not go here, because if we, maybe we should write it here for a moment. So this is not allowed. If you write the 2 here, then if we read the numbers from right to left and top to bottom, then we read 2, 1, 1, and then we encounter the first 2 before the first 1. So this is not allowed according to our rules. But we can add the 2 here, or we can add it here. These are 2 allowed choices. So let's copy this here. We already got the first 2 terms. So the 2 can go here, or the 2 can go here. Now, what other possibilities do we have for adding the 1s? We cannot add both 1s here and here, because then we would have 2, or maybe we should also write this, then we would have 2 1s in one column, and that's not allowed. So here, 1, 1, that's also forbidden. But we have some other choice which is allowed. So we can add 1, 1 here, and the other one down here. So 1, 1. And now what can we do with the 2? Again, the 2 can't go here, because that would give the same trouble as with the 2 here. But the 2 can go here, or it can go here. So we have 2 choices for the 2 again. One is we add it here, and the other one is we add it here. Okay, why can't we add it down here? That's because we study the case n equals 3, and then we never write down diagrams with columns that are longer than 3. So these are all choices we have here. And actually these are all choices we have in total. But now we said we do SU3. This means that we can always omit columns with 3 boxes, like this one, and even these 2 here. So we would write the result as follows. Let's say it's this diagram here, first one, plus, and here we omit the length 3 column, and here also, and here we even throw away 2 columns and retain just a single box. So this would be our result. And now we said we check dimensions. So what's the dimension? What are the dimensions of the irreps involved here? We could count standard tableaus, but maybe it's easier, or it's faster if we use the hook rule. So what is the, how do we calculate this dimension here using the hook rule? Sometimes it's convenient to just write the diagram again. Then in the denominator we need the hook length. So there's a 3 here, and a 2, and a 2, and a 1. and then I use these vertical bars here, in order to indicate that we multiply all the numbers in the diagram. And what do we need in the numerator? We start with this 3 here, this n here. It goes on the diagonal, and if we go to the right, we increase, and if we go down, we decrease the numbers stepwise. So here we can cancel 3, and we can cancel these 2's with a 4, and then we see that the dimension is 6. So that's for the first diagram involved, and for SU3. So this was 3, it depends on the 3, that's the number that goes here in this first box. Now what comes next? Maybe like this. What's the dimension of this one? Let's just do it in the same way. Hook length in the denominator, 3, 1, 1. And here we start with a 3, and there comes a 4 and a 2. And we can cancel the 3. And what's left? 4 times 2, 8. That's the dimension of this representation corresponding to this diagram. Then we have this huge diagram here. So what's the dimension corresponding to that one with these 7 boxes? Let's draw it here. Again, we need the hook length in the denominator. 1, 2, 3, 4, 5. It's a 5 here. Yeah. 5. And then this one here is a 4. Here we see a 3. This is 1, 1, 2, 3. Okay. And here we start with 3, 4, 5, 6, and here it's 2, 3, 4. Now we can cancel again. The 5 and the 5, the 4 and the 4, the 3 and the 3. And there's one more 3 here and a 2 here. And now we have 6 times 4, which is 24 for this dimension. And there's this one here is left. So the dimension for this one, what's that? Maybe that was a bit small for entering hook length and the other numbers. Okay, 4, 2, 1, 1, and here we have 3, 4, 5, 2. Let's cancel the 4 and the 2, and then the dimension is 15. Well, and the dimension of the one box diagram, that's n, and n is 3 here. So now we can check whether this works out. Here we have 6 times 8, and here we have 24 plus 15 plus 6 plus 3. So 24 plus 15, that's 39, plus 9, that's 48, and that's the same as 6 times 8. So we didn't make a mistake here.